All right, so today is day 10, last day of the unit, and we're going to talk about how to solve radical equations, but when they have rational expressions instead. So you might find this a little bit easier. It's pretty much the same things we did yesterday. It's just it seems to me it seems a little bit easier to solve. I don't know why. But anyway, so how could you solve this guy? Well, how I could solve this guy from yesterday would be, I got a radical by itself, so I could square both sides. So x plus 1 equals 9. And then subtract 1 from both sides, so x would equal 8. Now, what happens when the radical equation is written as a rational expression? So instead of the square root of x plus 1, I have x plus 1 to the 1/2 power, which is the equivalent. It's the rational exponent equivalent of square root is 1/2 power. So in order to get rid of a 1/2 power, it's the idea of taking a power to a power. So if I had a to the m power and I raise it to the n power, that's the same thing as a to the m times n power. So you're going to multiply those powers together. I want this to be a first power, because if I had x plus 1 to the first power, that's just x plus 1. Well, what do I multiply 1/2 by to get 1? Okay, and that's the reciprocal. It's what we did when anytime you're trying to divide by a fraction, you multiply by the reciprocal, or there's so many different ways we talk about reciprocals. So the reciprocal of 1/2 is a 2, so I'm going to take all of this to the second power. I'm going to take that to the second power. Notice it's the exact same thing. I'm going to square it. I'm going to take it to the second power, and that's because 2 is the reciprocal of 1/2. So if I've got to the 1/2 power raised to the second power, that says multiplying together. So half of 2 is 1. That's just x plus 1 to the first power. On the right side, I got 9. So this, when I subtract 1, is going to be 8. So basically, what power would you need to raise each side to make the exponent 1? Well, if the power is 1/2, you raise it to the 2 over 1 power. If the power is a 1/3, so let's say this was a 1/3 power, well, the reciprocal of that would be 3 over 1. If the power was a 2/3, what's the reciprocal of 2/3? You take that to the 3/2 power. So you take both sides of the equation to the 3/2 power, because 2/3 times 3/2 would equal 1. What if the power was 5/2? What if this was, instead of 1/2, it was 5/2? Well, I'd multiply the 2/5 power. I'd raise it to the 2/5 power. Okay? So, same thing as yesterday. We need to get, yesterday we said get the radical by itself. Well, here we got to get whatever is being raised to a power, which is the base, and the base is another name for that. Get the base by itself. So this is the base. This is what's being raised to the 1/2 power. That means the 4 needs to find somewhere else to go. So I'm going to divide both sides by 4. So this side, it would just be n plus 1 to the 1/2 power. Over here I got a 4. 16 divided by 4 is 4. Now, I want to get rid of the 1/2. The reciprocal is 2, so take it to the 2 over 1, or square it. Power to a power, multiply them together, that's 1. So it's n plus 1. And then 4 squared is 16, subtract 1, so n is 15. Okay, if you plug that back in, 15, so 15 plus 7, what is, and that doesn't work. I'm just looking at that. 15 doesn't work because I made a mistake here. This should be a 7. 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 That should be a 9. That makes more sense. Because if I had a 15, 15 plus 7 is 22. Can't square root 22. Nicely anyway. So don't let your mistake be you copied it down wrong. That'd be a really dumb thing to do, right? So anyway, so if I plug 9 in, 9 plus 7 is 16. Take the square root of that. So if I take 16 to the 1/2 power, that's 4, and then multiply by this 4, I get 16. So it checks out. Let's see here. So this guy, it's being raised to 3/2 power, which is the same thing as cubing it and square rooting it. If I was using radicals, that's a 2-step process. But since I'm using rational expressions, I can undo, basically I'm undoing a cube and a square root at the same time. So the reciprocal of 3/2 is 2/3. So I'll take this to the 2/3 power. So the left side is just 4x minus 3. On the right side, we're trying to figure out what is that to the 2/3 power. So if we're doing this mentally, that'd be the cube root of 125 squared. It's always easier to cube root first, or to always do the root first. I don't want to square 125 and try to find the cube root of that. That's too big of a number. So let's cube root it first. Okay, and that would be, what, 5? So the cube root of 125 is 5. And if I square that, I haven't done the squared yet, that's 25. And now it's just a normal old equation to solve for. So plus 3 plus 3, so 4x equals 28. X would equal 7. Okay, you want to plug that in the calculator. You can actually check this very quickly in the calculator. So I take 4 times 7 is 28. So I'm going to have 28 minus 3. Raise that to the 3 divided by 2 power. I get 125. So I know I got it right. Okay. So a couple more here. I've got this right here is the base. So I need to get that by itself. So the 2 needs to get out of there. So if I divide both sides by 2, I get x over 2 minus 2 to the 2/3 power equals 4. And now the power I'm going to use to get rid of 2/3 is a 3/2. Okay, so on this side I'll have x over 2 minus 2. And then on this one, this is the same thing as the square root of 4 cubed. Do the square root first. So square root of 4 is 2. 2 cubed is 8. Then add 2, so x over 2 equals 10. Multiply by 2, so x would equal 20. Again, you could check that out pretty quick. So 2 and then in parentheses, now 20 divided by 2 would be 10 minus 8. And then that would be to the 2 divided by 3 power. Uh-oh. Let me go back and check this. Oh, I see what I did. I was doing mental math in my head. It's minus 2, not minus 8. I was subtracting 2 in my head and putting 8 down. There we go. Now I got the 8 that I originally had. I say it's going to be easy, and then I screwed up myself. So there you go. So this last guy now, all of this is the base being raised to the 4/5 power, so it's by itself. That means I can just take this. Reciprocal is 5/4. Reciprocal is 5/4. So on this side, I have 3x minus 1 divided by 2. On the other side, that's the 4th root of 16 to the 5th power. The root is always easier, so do the root. The 4th root of 16 is 2. 2 to the 5th is 32. And from here, solve like normal. So multiply both sides by 2. 64, add 1, add 1. So 3x equals 65. Divide by 3. That does not divide evenly, so you can just leave it as 65/3. Just leave it improper and write it as a fraction. Okay, so pretty short and sweet lesson there. Big idea is whatever is being raised to a power, get it by itself. Then to undo that, do the reciprocal of that exponent on both sides, and go from there. So that's why I think it's easier. You can do 2 steps in one. Like I'm getting rid of a root and an exponent at the same time whenever I multiply by the reciprocal.